Welcome to my channel. Today we are going to solve a nice geometry problem. Given a circle and a triangle, this triangle with side length 13, 14, 15. These are the points. This is A, this is B, and this is C. So this is the given information. We need to find radius of the circle. Let's see how to find this. If we draw a line from C to another point, suppose if we draw like this, name it this as D. This line is nothing but height of this triangle, isn't it? So that's why let's name it as H. And we know that AB length is 14 units and we don't know AD length. So that's why let's consider AD length as X. If AB length is 14, AD length is X, then easily you can find that DB length. So that is 14 minus X. And what you observe here, the CD line is perpendicular to AB length, isn't it? So that's why it has angle 90. Now this line is dividing this triangle into two triangles. One is ADC triangle and another one is CDB triangle. So let's observe these two triangles now. So in ADC triangle, at D we have 90 degrees. That means this is the angle. In A, that is the angle. If A is the angle opposite side is CD. Is nothing but H. And this angle adjacent side is AD, which is X. Hypotenuse is AC, which is 13. ADC is a right angle triangle, so we can use Pythagorean theorem here, which is hypotenuse square equal to opposite square plus adjacent square. So that is 13 square equal to H square plus X square. So H square equal to 13 square is nothing but 169 minus X square. Consider this as equation 1. Now take this another triangle which is CDB. In CDB, D is 90 degrees. So angle, this is the angle. So if B is the angle, B opposite side which is CD, which is nothing but H, and adjacent side is DB, isn't it? So DB, the length is 14 minus X, 14 minus X, and then hypotenuse is BC, is nothing but 15. So it is also right angle triangle, so we can use Pythagorean theorem here also. So that is hypotenuse square equal to opposite square plus adjacent square. So here we have H square and here we have X square. All the terms are in one variable, that is easy to solve. In the first equation, in H square we have in X terms. So let's use this plus expand this A minus B whole square form, which is A square plus B square minus 2AB. So that is equal to 169 minus X square plus 14 square is nothing but 196 plus X square minus 2 times 14, which gives 28X. Here minus X square plus X square gets cancelled. So you left 169 plus 196, which gives 365. 365 minus this 28X. In left hand side we have 15 square is nothing but 225. So that means 28X equal to 140. So X equal to 140 divided by 28, which gives 5. So the X value is 5. We know the X value. Let's substitute in equation 1. Then we can find the H value also. So H square equal to 169 minus 25. That is 144. If H square is 144, the H value is 12. So we found H value is 12 and X value is 5. After draw the CD line, we found this length, which is, this is 5. Our goal is to find radius. So that's why let's draw a diameter. This is our center. If we draw from C to, name it this as E, this is our diameter. If you connect E to B, so from here to here, so we made a triangle. Now here, recall the inscribed angle theorem. First I am going to explain about inscribed angle. Suppose if we have a circle, this is a center, isn't it? Just make it 2 points on the circle and just draw the lines. This is nothing but your arc, isn't it? This is your arc. This is your central angle. Instead of drawing this central angle, if you draw 2 lines across the center, just like this, if you draw like this is nothing but inscribed angle. Now let's come to the theorem. The theorem states that number 1, the inscribed angle is half of the arc. If you have a circle, then if you draw an inscribed angle like this, so this is your arc, isn't it? Suppose if you draw a diameter, see, if you draw a diameter, it looks like a semicircle. In semicircle, the angle is 180 degrees. We know this. That means this arc length is 180 degrees. The theorem says the inscribed angle is half of the arc. Inscribed angle is 90 degrees. Inscribed angles of semicircles are always right angle triangle. Let's go to the statement 2. If you have a circle, if you draw an inscribed angle, just like here to here, this is your arc, isn't it? Suppose if you draw here to here, but this inscribed arc is same. Suppose if you draw from here to here, but this angle also, the arc is same. You can create more and more angles like this because all those angles intersect at the same arc up here. It means that they all must be concurrent. Now comes to the statement. The second point, the inscribed angle theorem states that inscribed angles subtended by the same arc are equal. So that means this angle is suppose if you consider as alpha, and this angle also alpha, and this angle also alpha. So all the angles are equal. What we did here, we draw a diameter COE. If we draw a diameter, this is your diameter COE. So that means this is your arc. If you consider this as arc, and here E to B, if you draw an inscribed angle here to here, so this is the inscribed angle. So if the arc is 180 degrees, it's a semicircle, then this inscribed angle, which is B, it is 90 degrees according to the first statement, isn't it? So the angle B is 90 degrees. Let's come to the second statement. So draw a circle and consider this as arc. This is point B. If you draw from here to here, this is the inscribed angle. If you draw from here to here, so these two angles are equal according to our second statement. So we are considering this as arc here, and these are the inscribed angles. So if this is A, this is E. If this A angle is alpha and angle E also alpha, isn't it? So that's why angle A equal to angle E. This is from statement 2. From statement 1, we know that angle B is 90 degrees. And also we know that at D, the angle is 90 degrees. That means angle D is equal to angle B. In triangle ADC, angle D is 90 degrees. And in triangle CBE, angle B is 90 degrees. In triangle ADC, angle A is considered as alpha, and triangle CBE, consider these two angles are equal, so you consider this as alpha. So angle E is alpha. In two triangles, if the corresponding angles are equal, their corresponding sides ratio also equal. Use that property here. Let's take their corresponding sides. This is A, G, C. We are taking B, this is E, this is C. This is 90 degrees and this is 90 degrees. So let's take the corresponding sides. So AC, we can write this as AC. This is AC over CE. These are the corresponding sides. that is equal to what we have, CD over CB. And we know that AC, the length is 13 units. Let's substitute the values here. AC is 13 over C is nothing but diameter. We don't know that. We need to find that. And CD, where is CD? So this is CD is nothing but H. H, the value is 12 over CB, the value is 50. From here we do cross multiply, then D equal to 13 times 15 over 12. After cancelling, 3 times 5, 3 times 4, so then the diameter value is 65 over 4. We know the diameter is equal to 2 times radius. So then radius equal to diameter over 2. So that is equal to 65 over 2 times 4, which gives 65 over 8. So this is the radius value. So therefore radius, the value is, if you divide this, then you will get 8.125 units. This is your radius. I hope you like this content. If you like this content, please subscribe to my channel. Thank you for watching.